For number 1 on the homework that's due next class, working with the introductory to plotting points, writing equations, and graphing equations using input and output. The first problem, we have a grid, a coordinate plane, that does not show any increments, and we have to plot the points. So the first point dictates the scale for the rest of the points, and we need to maintain the same scale on both the x and y axis. And so what I'm showing you here is how is some realistic coordinates for these points. Oops, I'm going to make that 6. Now, I'm just changing a few of them because after I do a few of them, then I can see that the scale was a little bit off there. But really, in the end, it doesn't matter exactly. It doesn't matter if you're totally exactly correct. I don't want to see increments. I don't want you to do tick marks or to measure. I just want you to use some spatial reasoning. So things that would be wrong, for example, would be maybe if you were looking at this coordinate right here, 5, -8. It would not make sense that this would be -20. Even though it's pretty far away, it's not so far away. It wouldn't make sense that if this represented -4, and this looks like it's about halfway in between, then it would make sense that this was -8. If this were -4, that couldn't be -20 because this -4 here, this distance from there that's equal to this distance here, there wouldn't be 5 of those distances down to get to this point. Okay, so you want to just maintain the scale that you choose from the first point. For the next problem, we have a graph, and we have to find the equation of this line that passes through the 2 points, -10, -3, and 4, 2. To set up the problem, we have to kind of explore this graph and focus in on some things. And these things that we have to focus on are the slope and the Y-intercept. The slope is the change between the output and the input of 2 points on the line. That means movement. We would move up to get from -3 to 2, and we would have to move to the right in order to get from -10 to 4. And so this slope, we're moving in the positive direction of both between the output and the input, and so a positive divided by a positive is a positive. The Y-intercept is the point where the input produces 0. A lot of people refer to it as the point that crosses the y-axis, but that's not a good definition of it. A good definition of it a definition that works in every situation, no matter if it's a graph, if it's a real-world problem. The input that produces an output of 0, and that's this point right here. And a good guess for that point would be 0, -1. In part C, we have to find the slope of the line using the 2 points, -10, -3, and 4, 2. And the slope formula that we need to use is m equals y2 minus y1 divided by x2 minus x1. Now, technically it doesn't matter which point you designate as x1, y1. So I'm going to go ahead and just do -10, -3 as x1, y1, which means that 4, 2 is x2, y2. It's really helpful if you label your points with x1, y1, and x2, y2, because then when you substitute in your points into the formula, there's less likely a chance you're going to make a mistake. So let's see what the slope would look like with the points plugged in. M equals 2 minus -2, 3, and -10, no. Let's try that again. Positive 4 minus -10. And the result, positive 5/14. Part D asks if it makes sense that 5/14 could be the slope of this line. So let's see. The way that you check it is that on your graph you actually count the units between the points. So you're counting the distance between -3 and 2. To get to 0 it would be 3 units, and then get to 2 it would be another 2, and so that's positive 5. Then to get from -10 to get to 0 would be 10, and then to move another 4 units to get to 4, it would be a total of 14. And so if we divide the change of the output on the graph by the change of the input on the graph, we get 5/14. And so yeah, 5/14 does make sense as a slope of the graph. Now, it's not going to be realistic for you to count the units on every single graph in every situation, but you should be able to reason out if the slope does make sense on any part of the line. Counting on the graph is one way, just kind of looking at your points. For example, if a common mistake that might be made solving for the slope here would be to get a negative slope of 5/14. And that doesn't make sense because we already looked and decided that in part A that it's going to be a positive slope. Now, if there's a contradiction between part C when you solve for your slope and part A, whether it's positive or negative, then you know something's wrong. You either made a wrong judgment to begin with or you did a computational error. But regardless, you need to go over your work and just double check and make sure everything is okay. Now in part E, we're going to use our slope and the slope-intercept form of the equation, which we all lovingly call y equals mx plus b. Now, in our work, we're going to use one of the coordinates, I'm just going to pick 4, 2, to put into the equation. 4 is x, and 2 will be y. 5/14 is m, and we're left with the unknown b that we will solve for. This is what the equation looks like. 2 equals 5/14 times 4 plus b. And continuing to solve, we get 2 equals 20/14 plus b. Now reduce this fraction 20/14 before you subtract it. That becomes 10/7, and then subtract 10/7 on both sides. Change the denominator of 2 to be 7, which means the numerator has to be 14. And so we have 14/7 minus 10/7 is equal to b. And then we get that b is equal to positive 4/7. Now substituting back into our equation y equals mx plus b, we have our slope as 5/14 and our y-intercept as 4/7. And so our equation is y equals 5/14 x plus 4/7. I did not substitute my coordinate back into the general equation. This equation is the equation that will help you graph this line no matter what points that you have. For the next problem, you're given a graph, a coordinate plane. You have to graph an equation. In this case, y equals 2/3 x minus 10, and you're given some inputs. Now, these inputs, I only have 4 right here. On your paper, I think I might have given you like 6 or 8 or something like that. But these are just some samples of how to deal with some fractions, substituting it in, and then what it would look like if I plotted them. So substituting in an input of -1, we have that y is equal to 2/3 -1 minus 10. And so solving this, y is going to be -2/3 minus 10, and that is -10 and 2/3. The coordinate of this input-output pair is -1 and -10 and 2/3. This is called an ordered pair because we have an associated input with the output that it produces. And through -3/4, the next input, we have y equals 2/3 times -3/4 minus 10. And multiplying the fractions, you have to multiply the numerators together and then the denominators together. And we get that y equals -1/2 minus 10. So y is equal to -10 and 1/2, and the ordered pair would be -3/4, -10 and 1/2. 0 is easy to plug in because when you multiply 0 by the slope, you get 0, and so you're left with y equals -10. And so the ordered pair for an input of 0 is 0, -10. 4 2/3 is a difficult one, and I put this one in here because even this one is not actually too difficult to deal with. We just have to make sure that we remember the multiplying fractions rule and also subtracting and adding fractions rule, and then I'm going to show you how to put it into a mixed number so it's easier to graph. So first, we're going to change, instead of saying 4 2/3, we're going to change it into an improper fraction so that it's easier to substitute into our equation by when we multiply it by the slope of 2/3. And so when we multiply, it would be 28/9. 2/3 times 14/3 is 28/9 because you have to multiply the numerators and then the denominators. Then we're going to have to rewrite 10 with a denominator of 9, which means that the numerator will then change to 90. And so we get y equals -62/9, and then that as an improper fraction is going to be as a mixed number is going to be -6 8/9. And the way that you put it into an improper fraction, I'm going to show that on the next slide. But first, the ordered pair is going to be 4 2/3 and -6 negative 6 and 8/9. So often when we're doing these problems with the fractions as a slope and fractions as the input, I showed you how to substitute in, change into an improper fraction, but in order to plot, it's much easier to deal with an mixed number than an improper fraction. So I'm going to show you how I got negative 6 and 8/9 from negative 62/9. So I'm going to use long division. You could potentially do this in your head as well. I'll tell you with long division, basically what we're doing is we're saying that 9 goes into 62 6 times. 9 times 6 is 54, and then 62 and 54 have a remainder of 8. And so we have the remainder of 8 and then write the remainder over the fraction. So what this fraction 6 and 8/9 says is that 9 goes into 62 and has a remainder of 8, and that's kind of the fraction left. It's not quite a whole, and so it can't be added to the 6. It's just almost 6. 6 and 8/9 is, almost 7. And it has to be negative because we have a negative 62. And so what we show here is that negative 62/9 is equal to negative 6 and 8/9. Now, I've already done some plotting, and I've showed down here, this is not, this 10 down here is not the plot, but I just showed the plot of all of the coordinates that I just showed you how to substitute in the inputs and the outputs. And so it's pretty easy, you can think of negative 1 and then down negative 2 and 10 and 2/3, but I want to focus on how we can figure out exactly how to graph and plot the points. Now I want you guys to use some of your common sense. I want you to think about what it would look like. So the first point that we have here, this is the point negative 1, negative 10, and 3/4. Negative 10 and 3/4 is almost at 11. If this is negative 10 and this is negative 11, negative 10 and 3/4 is almost at 11, so that's why I've showed it really, really close to 11. Then this point right here, negative 3/4 and negative 10 and 1/2, it has to be about halfway between negative 10 and 11, and so we have, and it has to be almost to negative 1, and so we have almost to negative 1, halfway in between negative 10 and 11. 0, negative 10, not going to explain that. I think you got that. And then over here, the point 4, we went 4, 1, 2, 3, 4, and 2/3, which is almost to 5, 4 and 2/3, and then down to almost 7. Now, okay, yeah, granted, it's not as accurate, but the way that we check and make sure that we have done all of our plotting and math correctly is that if you take these points and you can draw a line, a straight line through them, pretty good straight line, this will tell you this is the equation, y equals 2/3 x minus 10, and all of your coordinates should make a straight line.